Great, we're working and beautiful. Ooh, I do need to mute my audio from the stream. There it goes. All right, so hi, I'm Basil. I've been working on an OpenCode plugin for what I call Context Bonsai. Context Bonsai lets the LLM edit its own context. The context is the conversation that you're having in a session. So when you send a message to Claude or GPT or whatever model you're using, that message is part of the context, and the LLM responds back with its own response, and that's part of the context. The LLM might perform tool calls. The tool call and its results are part of the context, and it builds as the conversation progresses. Every time any message happens, it's tacked on to the context, and the LLM sees the entire context every time it processes a message. So the Context Bonsai feature, it's limited right now. It's got the first parts. It's sort of the broader concept of you can cultivate this concept. Now, the very first part of it, it lets you prune out parts of the context specifically. So there's the normal LLM harnesses, Claude Code, Codex, Gemini CLI. These tools usually have a feature called auto compaction, where once the context grows too large, there's a limit to how large LLM models can handle. When it gets to a certain size, the LLM harness will prune off the beginning of the conversation and replace everything with a summary that's generated by the LLM model. It asks the model, please summarize this entire conversation, and it gets a summary back. And then it starts basically a new session with just that summary, possibly the last couple messages, but that summary is there, and then you proceed from there. And the outcome of this is pretty disastrous. You might as well just start a new session at that point. The compaction summary is almost never sufficient to actually continue productive work. So there's lots of ways that people have found to work around this, including just making it part of your workflow to frequently restart the session over and over again. You sort of externalize anything that happens in the session in files, so that on the next session you can read back information from those files. This is going to be another workaround for the context limitations. So the tool lets the LLM pick a certain part of the conversation, and it asks the LLM, it sends just a portion of the conversation to the LLM and asks for a summary of that portion. And then the harness will cut out just that portion of the conversation and replace it with the summary. I also have it that I ask the LLM to provide some keywords that can be used for indicating to the LLM more about what's included in the hidden messages that the LLM will no longer see. And then there's a separate tool called Retrieve that lets the LLM retrieve back those messages that were hidden in case it actually does need the information that's in there. So the idea is that you start work, maybe the LLM is tasked with a certain thing, but partway through the tasks, it goes down a long debugging route. Like its first attempt failed, and it tries a few things, and eventually it works out how to accomplish a task, and it solves it and moves forward to the next task. Well, that entire process of debugging and trying things out and failing and learning and trying again, it's no longer necessary. It doesn't need any of that to be able to continue forward its progression with whatever the larger goal that it has is. So it's beneficial to be able to clear that out of the context. This helps not just by avoiding the limit that you run into with the maximum context length, but it also helps the LLM stay focused. So as that context builds and builds and builds, there's parts of that context that are very useful and relevant and help the LLM be productive towards whatever you're trying to do. but there are parts of that context that are unproductive or even anti-productive. So at minimum, they just uselessly consume part of the context. At worst, they actually damage the context and confuse the LLM and cause it to misbehave in further, like as it continues its trajectory through its goal. So the Context Bonsai feature helps with that. I've developed it as a modification of OpenCode. I forked OpenCode, developed it, and now it's working for the most part. And I'm going to convert it into a plugin. So I have previously worked with an LLM, or several LLMs actually, to figure out what the minimal amount of changes to OpenCode are needed in order to support this feature set as a separate plugin. So we have that. We have a document. We have a few documents. One is the project.md that sort of defines what the Context Bonsai features do. There's a project proposal for, this is focused specifically around that minimal set of OpenCode changes that need to happen. And then I also have a smaller document that's distilled from these that is like it's called upstream proposal, where it's much smaller and it's just meant to talk with the upstream developers and ask them if they would like to have any input before I start working on these modifications. They weren't interested in any input, but they did point me to another interesting project, which I'll probably talk about at some point on these live streams. There's another project called dynamic context pruning. It sounds very similar, but it works completely differently. It's very focused on the tool call part and eliminating duplicate tool calls. It does a few other things, but that was an interesting read. Anyway, I'm in the process of converting this to a plugin. In the last couple of live streams, I've gone through the planning process. So we did the research and we have the proposal, but it's not very detailed. In order for the LLM to actually make the changes, I prefer to have a very detailed plan that spells out exactly what the LLM should do. And I want to remove as many decisions that the LLM has to make as possible. I want to pre-decide everything interactively with myself and LLM agents looking at the code, reasoning about it, and talking about it. So that was what the previous couple of live streams were focused on. And in this live stream, the plan is pretty much resolved. There was one part of the previous stream that I realized I wanted to dig into further. And that is, within this plan, we're proposing creating a new way to update the storage mechanism that saves the session, because this project, I've mentioned that it like cuts out part of the conversation. Well, that is modifying the actual way the messages are stored. And in this project proposal, it's proposing that we add a new method to OpenCode that lets us atomically do this. There's currently mechanisms, there's methods in there that let you update messages, but there's not one that lets you read messages, modify the messages, and then write it back to the storage. So this proposed adding that, and I wanted to make sure it wasn't feature creep. So this is the session right here. I asked Claude to read the project and the project proposal documents. And then I asked, well, first I wanted to make sure that it understands what I'm talking about with this atomic message update thing. And it does. Then I asked it about the current codebase's usage of the existing update message. And whether that's already used or something we're adding, just to make sure that that part of the code base is in the knowledge of the LLM. It's in the LLM's context now. So the LLM has more understanding of what that method is and how it's used. And then I asked this question: would any of the existing uses benefit from the new atomic version of this method that we're adding? And I wanted to do this to make sure that we're not sort of adding scope creep. If there are already cases in the code base that would benefit from this atomic message update method, then we might want to take a step back and look at the code base more specifically. Maybe the LLM thinks we need this atomic method, but in actuality, the way it's used, it never comes up that there's an opportunity for the read, modify, write to be partially applied, or to have the after the message is read, the message is modified by some other part of the code base, and then we apply our own changes and clobber out whatever happened before. Maybe that's simply not possible in this code base. And I just wanted to make sure we weren't adding something that wasn't really necessary. So this went through the code base to understand the patterns that are currently used with the non-atomic update message method. And it determined, the existing code base simply has no need for the atomic message update, because everything that uses the message update, it's the owner of that data. It has the data, it generated it, or it creates it, and it writes it. It updates it itself. So there's no opportunity for, or there's no benefit from it having some sort of atomic method. So I think it's valid. I will leave it in the plan and go ahead and have the LLM work on adding this update message atomic. So I wanted to include that. Part of these live streams is specifically about showing how I work with LLMs to get work done. So this is part of that, just sort of demonstrating the way I dig into code and look at things and make sure that these plans are on point before the development process starts. So that was satisfactory to me. So I'm ready to kick off the development process. Oh, that was a separate thing. I should break this out into its own window. Detach and move it somewhere else. Okay. And this was where, from the last session, we did some work on the plans. I'm going to sort of clear out everything we did from the last session and start fresh. Okay. Now I think I'm going to use Claude for this. It's the one that I've used the most in the past. So I trust that the process I'm about to go through is going to function adequately in Claude. I'm actually currently interested in using GPT a lot more in my development efforts because of recent limitations Anthropic has put on the use of the subscription plans. They no longer allow you to use the subscription plans with third-party tools like OpenCode. Which means this feature that I'm developing, I'm not going to be able to use it with Claude anymore. I'm going to have to use one of the other models. But my sort of development orchestration process has been tuned towards the way Claude works. And if I take those documents and try to use it with GPT or some other model, it's probably going to hit some... it's not going to behave quite the same way. I'm probably going to have to make some tweaks to adjust it for whatever other model I use it with. So I'm going to use Claude for this. And I have a set of documents that I use for the development process. There we go. Read that. So the development process, I have it set up as an agent that orchestrates progressing through the plan, and that orchestration agent will launch subagents to do the development work. So it's read it. Now I need to get the path to the actual plan. There we go. Whoop. This Epic tool context enhancements is the plan that is specifically about modifying OpenCode in this minimal step necessary that can support the plugin that I will develop, that I will sort of port from my current forked OpenCode. I will port that and turn it into a plugin instead, but there's still these changes needed in OpenCode. So this Epic tool context enhancements document has that. And just by asking it to read it, it understands, it read that it's an orchestrator, it read that the plan, and now it knows what to do. So it's going to launch some developer subagents. Oh, before I do this, I'm going to turn off the permissions stuff. There. Okay. So at the end of the previous stream, I mentioned that I'm going to go over these documents, the orchestrator document and the other documents that control how this process works. And as we're reading the document, we're going to observe the LLMs and actually see it doing the things that are specified in that document. Okay, so it's created this tracking table, so it knows within the epic there are 6 stories. So it's created a row for each of these stories, and it understands what the status of each of these stories is. Okay, and it's starting story 1. Task is what Claude Code calls a subagent. So this is its own subagent, and that subagent has gone off to start working on the first task. All right, now I think I'm going to have this window something like that. And while that is going, we'll take a look at these documents. Okay, so the orchestrator agent, it really needs to not do any implementation at all. And there needs to be lots of information in this document that says it shouldn't do that, because the Claude model, Claude Opus, Claude Sonnet, all of them are very eager to just do the work. They want to be helpful, they want to get the work done, and they're trained on that kind of getting work done. So we have to sort of counteract that training and tell it that its job isn't to actually implement that work, it's to orchestrate this process. So that's what the first part of this document is. It's trying to get it to not do development work, but instead to actually orchestrate this process. So it's supposed to launch subagents for all the implementation work. If a subagent fails, it should just try it again. It can modify the instructions, because usually when the agent fails, the agent will respond with something that helps the orchestrator know what went wrong, or the orchestrator can sort of take a look at the output of the worker and figure out what it might have done wrong. So it's told to just restart if it fails. Right, and trust subagent reports. That part, something happened that the subagent returned some results. Then the orchestrator decided to actually look at the output of what the developer subagent did, and the orchestrator understood what the developer did incorrectly and kind of messed up the whole thing. So at this point, this is here, but it's sort of temporary. I'm trying this line out and seeing how it goes. And again, more information of, do not do implementation, launch a subagent for everything you do. The orchestrator needs to protect its own context window because this is the long running one. And actually, I might someday just eliminate the orchestrator as an agent and convert it into code and just have code that can progress through the task and launch subagents because it's rather formulaic. But right now there are some LLM necessary parts of the process. I would need to spend quite a bit of time doing projects with code as the orchestrator to figure out where it trips up, where the process falls apart, and it needs like an LLM analysis or decision to continue. So right now, the LLM is an agent, and it's responsible for making tasks progress, and these can go on for hours at a time. So the orchestrator subagent needs to protect this context window. I don't want it to reach the limit and get auto-compacted and have to start over again. And actually, this is one of the main things that will benefit from this Context Bonsai feature once it's done. I will add directions in the orchestrator agent document here to tell it when it's a good idea to summarize previous results. It's going to basically be every time it completes one of the tasks in a story. More about its mission, what it's supposed to do. Oh, yeah, actually, this has more information here. And we're going to make this one bigger because it has proceeded onto a couple of these steps. Okay. I've read the orchestrator. Oh yeah, part of the orchestration thing is to figure out where documents live, because these documents are passed as information to its subagents. So it has to understand where the project documentation is, where the orchestration documentation is. So it figured that out. It created its own tracking table. It figured out that it can do some stories in which stories can be parallel, which stories can be sequential. Here it's doing it again because I quit and fixed the permissions and came back and continued. Okay, then it launched a task developer subagent for story 1. Then it launched a reviewer subagent for story 1. So after the developer says it's done, it's almost never actually done. And the entire reason for this whole process I go through is because LLMs have this problem of doing incomplete work. It sort of doesn't complete all of the tasks or all of the steps in the document, or it might update one part of the code, but there are multiple parts that need updated, but it updates one part, it considers it that it's done, it feels successful, and it reports that it finished when it actually hasn't finished. So once the developer claims that it's done all of the work, it passes it on to a reviewer. And the reviewer does a standard kind of code review kind of thing, but it also makes sure that the task is fully complete. It reads the project document and looks at the output and sees whether everything that's in the document was actually satisfied by the work the developer did. And there are a couple of other interesting ways that I have the reviewer review the story, but I'll get to that if we proceed to the reviewer document part of this. And then once the reviewer is done, it launches a third subagent called a judge. So the reviewer can tend to pick apart way too much in a way that expands the scope of the project, which we do not want. Where we want development focused on the specific changes that I put in the plan, and we don't want it to branch out and start trying to fix other random things that the reviewer identified as problems. Because it may be existing problems in the code base, and it says, the reviewer might say, hey, the way you're doing this is suboptimal. If you refactor this part, where this part is completely set, it's deep in OpenCode and not necessary for this actual change, not necessarily OpenCode, but whatever project you're working on, it might suggest making pretty broad changes, and we don't want that. The judge reviewer, its goal is to prevent that scope creep from happening. It's also responsible for making sure that the sort of trajectory of completing the task is happening, because it can happen that the reviewer creates feedback, then it goes back to the developer and it will make changes based on that feedback. Then it comes back to the reviewer, and because each of these is a new, fresh LLM session, they don't have memory of what happened before. The reviewer might find something and suggest exactly the opposite change. And the reason is because there are always trade-offs to decisions. And you can choose one way or the other, and they have trade-offs. And just because you could do it some other way, it doesn't mean it's the best way to do it. But the reviewer might, it's not good enough to consistently suggest the same thing every time. So the developer can fix something, send it back to the reviewer, and then the reviewer can say, oh no, you might want to do it this way, where it's what the original one was, and it can just bounce back and forth and not make progress. The judge is there also to help prevent that from happening. And it's also there to prevent perfectionism or minor things that, sure, you could fix that, but we got to get the project done. So this falls below the line of absolutely needing to be fixed. So the judge takes all of the reviewer's notes of suggestions, and it says yes or no to each of those suggestions. And then the orchestrator takes that output and passes it back to a fresh new developer, and the development happens again. So this goes through the loop a few times, and so far, I've not had it be circular. It tends to always progress through the task and move on to the next story that it has to implement. But in this case, story 1 was approved as is. No changes were needed. Most of these stories are very simple. They're pretty small changes. The LLM estimated that maybe 50 lines across all 6 stories, maybe 50 lines have to change. So it doesn't surprise me that it passed story 1 as is. Then story 6, doing the developer, the reviewer, the judge, also approved as is. Now it's moved on to story 2. Okay, so while that goes, let's move back to the orchestrator document. Okay, so this sort of explains more about that. Coordinate the development of stories by launching developer subagents, launching reviewer subagents, and launching judge subagents, and manage the develop, review, judge loop. And it has a limit that it can only do 5, but it never really hits that limit. Actually, I guess it has a couple of times, but then I end up making a change to this document or to the reviewer or the judge. And it fixes it pretty easily. Let's see. There's information here about the dependency management of epics. So when we reviewed what the orchestrator was doing, I mentioned that it figured out which stories can be done concurrently versus sequentially. And this is the part of the document that describes that. Now, there's a separate document that I use when I develop the plan that the LLMs follow. And in that planning process document, it talks about how to figure out which stories can be sequential or parallel. And it embeds into the plan a graph kind of like this that says what can be done concurrently versus in parallel. So when I say the orchestrator figures it out, it's reading the document that the plan did the hard work of understanding what can likely be done concurrently. The orchestrator just reads this and understands what it can do in parallel and sequentially, and it will do that. Determine placeholder values. I talked about that also when we looked through the orchestrator stuff. There's like placeholders in the document that it needs to figure out the actual paths to these files so that it can hand them off to the subagents. So there's the orchestration instructions, there's the project specification files, scope and planning files. So the scope and planning files are my project.md and project proposal MD file that I mentioned before. The specification files are the epic file that you saw that I pasted in there, and siblings to that epic file, there are story files. For every one of the stories, there's a file that describes everything that needs to change for that story. So this figures those things out. If there's research notes, it will figure that out. And for this, there's a thing called project research.md that I made this time. That's not always there, and it's not always named project research, but usually the LLM can do a decent job of finding the research notes and using that. Those notes are used by the reviewer agent, as well as the overall the scoping and planning, the overall, like the projects.md, the project proposal.md file that I created. Those kinds of files, they're not always named that, but whatever the overall project files are, the reviewer uses that as part of its review as well. And I believe the judge does too. We'll find out when we go through those notes. Then per story files, I mentioned parallel development paths we talked about, state tracking. So when I pointed out that it created a table and it had a row for every story, this is the part of the document that caused that behavior. Oh, actually, we might want to look at this. So there's the state tracking table and the story status, but there's also failure log. So if it does have a problem where the developer simply can't proceed, or if it goes through the loop 5 times and still hasn't resolved, then it will log that as a failure. And I also have something in there. I'm pretty sure it will say to send me a Slack message if that happens. So because this is a long process, it usually runs for a couple of hours autonomously. Not on this one. This is a small change, but on big projects, it will run for hours. So I kick it off. I'll go do other projects. I'll go to lunch or whatever. So I like to have a message if it reaches the failure state. And the escalation log. The escalation log is when it has to actually ask me about something. It means that I missed something during the planning stage, and it doesn't know what to do next, and it needs me. So that's the escalation path, and it will log if that happens. Let's see where our agent is. Review story 2. Great. Okay, and so far it's still on its first iteration of story 2. And here's where it talks about the actual loop. It starts with the developer, then the reviewer, then the judge. And it just has specific information in there about how to launch the developer, what information the developer needs, what to get back from the developer, and so on. Same for the other agents. And then this phase 4 decision is after the judge gives back its yes or no to each of the items that the reviewer has. The decision is simply if the judge approved things, loop it back through the developer unless you've reached that max iterations number. If it's approved as is, move on to the next task. So that's this part. Oh, and the judge might say, it needs escalation or needs discussion. That's the escalation path. And this failed, that's the failure path too. Okay. Here's all the specifics about how to launch subagents. And this is written generically so that it can be used in multiple LLM harnesses. So the LLM harness is the tool that you're using to talk to the LLM. So here I'm using Claude Code, but OpenCode is an LLM harness, Kilo Code is an LLM harness, Klein is an LLM harness. These are the sort of shells that you interact with that gets the messages to and from the LLM. So each of these harnesses provides a set of tools that the LLM can use. So when LLMs launch subagents, it does that through a tool, and these tools are different in different LLM harnesses. Claude calls subagent tasks. Other ones call them subagents, and I don't know what other terms harnesses might use, but this is sort of written in a generic way, so that doesn't mention the tool name specifically, but it says, use your platform's subagent / subprocess mechanism. And I recently discovered that Codex still does not have a subagent mechanism, so I might add into here a way to do subagents outside of the tooling that the harness provides. I have been refining this process over the last almost a year now, and the subagent support didn't exist originally. So I made my own subagent support, and it's pretty simple. You just launch a subprocess. The subprocess launches an LLM harness in a way that doesn't require interactivity. And what I mean is, when you launch Claude or pretty much any agent, it opens and it waits for you to type stuff, and it's interactive. You type stuff and it sends stuff back, and you type more stuff and it sends stuff back. So you can make subagents using that process with tmux. Tmux, I might demonstrate that later, but tmux is a terminal emulator itself that runs inside of a terminal environment. So you sort of launch this text, like internal terminal emulator, and inside of that you can launch whatever LLM harness, like Claude Code, and then you can read the screen of that terminal emulator, and you can send keystrokes to the terminal emulator, and so you can interact with it that way. And I have created agent orchestration systems using that. But for this process, this developer review judge loop, interactivity is not desired or required. So there's a different way to do it, and you can do something like Claude's looks like this. -p means this is the prompt that I want you to send. And there. And by adding this output format flag, it causes Claude not to be interactive. It will just process the prompt and give me text as a result. And that way it's sort of one shot, and it works like that. So to create a subagent, you just have instructions that tell it how to create this prompt. I actually have it use a make temp file, or I use a temporary file. I ask it to put the prompt in the file, and then do something like, oh, I did this slightly differently. I meant to do this. So instead of just doing it that way, I can do, oh, interesting. It looks my message was cut off. I don't know why it says that, but I can do something like cat, and this would be like the prompt file. And by doing that, the LLM can use its file writing and editing tools to create a prompt, and then just launch the subagent like this. And whatever the output of this process is the report that the agent gives back. And that subagent, even though it's like a one-shot, I tell you and you give me back text, it can still use its own tools. It can write files and read files and do all sorts of modifications. So it can do useful output, even though it's not interactive, and even though it only gives back one body of text as the result. There's side effects that happen within the subprocess, such as modifying files, that cause this to actually be useful as a subagent. So so that used to be part of this document. I stripped it out because I used Claude a bunch. I used Hero CLI a bunch, and both of these support subagents as a normal feature. There's a tool for launching subagents, so I figured it wasn't necessary. It looks like all of them support subagents. Apparently not. Apparently it's still needed for Codex, so I might add a section back in here for how to launch a subagent. Okay, back to here. How are we doing? Story 2 finished. It was approved as is after just one revision. Okay, nice. Story 4, formalize messages on plugin tool context. And we're at the judge. The judge finishes pretty quickly usually, so I'm waiting to see if this goes through another iteration or if it's approved as is. Oh, it's going to approve as is because the reviewer found 0 issues. So yeah, that's going to move on to the next story, which is going to be story 5. Oh yeah, the judge will also make sure that tests succeed. So it's running the TypeScript checker right now. Okay, since I already know the outcome of this, it's going to succeed. I'll move on here. Okay, so developer subagent. Oh yeah, there's like 2 different prompts versus whether this is the initial task that the developer is receiving, or if it goes through that loop and it needs revision, because it needs to understand what revisions it's being asked to do. So there's a different prompt for how to launch a developer for a revision. The reviewer agent prompt is simple. Read the reviewer document and then review. It's given whatever story it's supposed to review. Here, like right now, it's on story 4, so it was given story 4 and the name of story 4 and the list of commits that make up story 4, and then additional context about what the story is about. And then here are some instructions for the reviewer, but the bulk of the instructions are actually in the reviewer document. We will get to those. Launching the judge, it's told you're the review judge. There is the path to the instructions. Evaluate the review findings. So it's specifically judging the reviewer's output. It's not judging the developer's output. And it needs to understand what iteration it's on, which commits matter. It verifies that what the reviewer said, those issues actually do exist. And it produces a report. And it can include previous judge assessments. Any that is okay. So the orchestrator is sending this prompt to the judge. So the orchestrator has seen all of the previous assessments that have come back from the judge, and so it can give the judge information about what previous judgments have been, and that way the judge can understand whether it's been flip-flopping or if it's actually trajecting towards completion. And which things are required reading if necessary. The story context is the path to that actual story file that defines the changes needed for the story. And then it's given, the basic read your instructions, do all of this stuff. Okay. Then information about how to manage dependencies between stories, and handling parallel work. So random things can happen if the agents are working in parallel, especially when it comes time for them to commit files. It's possible that even though the planning process is supposed to make sure that work is done sequentially, if they're expected to edit the same file, it is still possible that the developer has to modify a file that we didn't predict in the planning phase. And it can happen that there are commits that happen that sort of combine the work of multiple stories in one thing. So there's ways to detect these conflicts. So far, I've only run into this a couple of times. Periodically, we'll try to merge and figure out, if there are conflicts, how to deal with that. How to deal with failure when it happens. And it produces a final report once it's done. Oh yeah. If compaction happens, I should explicitly say if compaction happens, or really I need to run several harnesses all the way until the point when it auto compacts, and then right after auto compaction, I need to interact with the LLM to understand what it sees. How does it understand what just happened? Does it know the term compaction? Does it know that that's what happened? Things like that. And I'm gonna put those things in here for triggers of if for instance, Claude Code specifically says the previous session has been compacted, this is the summary, then in these instructions I can say, if the session has been compacted, go through these steps again. So this is what this part is about, but it's not fully developed yet. So far, I haven't really needed it because the orchestrator can run for so long, hours and hours, before it runs into problems that if there is a problem, it doesn't happen frequently enough for me to really spend time figuring out how to recover from compaction. It'll just be that, oh, it's been running for hours and it's not quite doing the right thing. I need to stop it and restart everything. But if it does happen frequently, or if I start doing projects that require more than hours, I can't imagine that happening between interacting or between providing it a whole new plan, then maybe this part will be necessary. But right now, producing a plan that causes the LLM to run for hours takes quite a bit of work. So usually I will get a plan ready and kick it off. And if I can start working on the plan for the next phase, then I will, or I'll go work on another project. But I can start working on the plan for the next phase. So usually if I wasn't doing this live stream, this would be working on its stuff, and I would already be working on the plan for defining the actual plugin. That larger project proposal thing, it has more than just the OpenCode changes. It has information about how to do the entire plugin. So I would take that overall plan and take that and make the actual implementation plan that has the specifics. It would be the epic document and all of the stories, or probably multiple epics for something that large, and all of the stories for completing the task. I'd be working on that part right now. And between doing that and having the LLM go through this development loop process, they kind of there's not really a need to develop a plan that would cause it to go for days or weeks. Although that is a different style of development that people do with LLMs. There's a way that you can just give an LLM goals and ways to track its progress and its learnings, and you just set it on a continuous loop. The Ralph thing people were talking about a few months ago is that style. You just put it in a bash loop, and you have it just loop until every thing identified in like some goals document is satisfied, and it will figure out its own development process and go and go and go. I don't. So that costs tokens. So it you're spending a lot more on tokens and less on your own personal time. I don't want to do that. For one, it's costs way more. I don't have the resources for that at this point. Like you can read about, there's a person named Steve Yegi, an engineer type person who has developed his own orchestration system to help this process work. It's more complex than the Ralph loop system. And he talks about, he has something like 5 Claude subscriptions to keep to have enough tokens for all of the work to get done, and even that's not enough. He says something like there's not enough tokens in the universe to satisfy the development. So I don't do that style. Another reason I don't do it is because I like to stay connected with the code and the changes that are happening, and I want to understand the changes that I'm making, the code, the output that's being produced, rather than just letting it go and produce some like a huge output, like a lot of changes, and then go study those and understand it all. I'd rather be involved as it goes along and influence it. I like it partly because I learn. So I'm working on OpenCode. There's a lot about OpenCode that I really know nothing about. And I'm slowly learning more and more about the internals of OpenCode as I work through this. And I find that beneficial and enjoyable. So that's the style I do. So that means that these plans have a lot of input from me on the planning stage. So that takes a lot of my time. So this development loop that it's going through, by the time that's done, I might be finished with the next plan, and I can just swap, or keep rotating plans through. So development will work on the previous plan I made, I'll work on the next plan, and when that's done, take this plan and set that on the developer loop and move on to the next plan or next project. Okay. That was the orchestrator document. Let's see where we are here. Story 5 of 6 was complete. 5 was approved as is. And yeah, it finished after only one iteration. It started, it did dev review judge, approved as is, and moved on. Story 3 is happening, developer, reviewer. The reviewer can take a bit of time. Oh, aha, this one's going to go through an iteration. Nice that we happened to see it right when it happened. So now the judge is going to look at these 3 issues that it found, and it's going to figure out if that's actually worth working on. And I might want to go specifically look into this. Especially if the judge rejects some of these issues. I want to see what it rejected and make sure that I agree. I don't always do that. I usually just let the development process go from beginning to end without it bothering me. How long did the previous judge take? Oh, it doesn't tell me. This judge actually should take more time because it's actually going to dig into these issues and understand them and try to figure out if they're on scope and they actually should be changed, or if they actually align with the project overall. So this one should take a little bit longer, which maybe we should look at the judge document next. Oh, it's called review judge, is it? Okay. Oh, the judge finished. Okay. Okay, the judge rejected the findings. So, and that was the end. Story 3 was the last story. Oh, it had something in story 2. Non-null assertion on optional language model in from plugin. The judge rejected it as out of scope. The only code path reaching from plugin always sets language model. The other tool.context construction sites never invoke plugin tools. Adding a runtime guard or making the field required would add complexity for an unreachable scenario. I think we specifically wanted it optional anyway. Interesting that that the reviewer even found it. Story 5, installed plugin fallback. Yeah, no, that's another thing. The reviewers asking the LLM to review your code will a lot of times say that if this fails, you really should have a fallback. When I usually do not want to fall back. I just want the failure to fail because it's usually a scenario that there is no sensible fallback. Let's see. An anonymous exports would get a file system path as a plugin ID instead of a clean name. Judge rejected out of scope. Anonymous exports would get a file system path as a plugin ID. Oh, yes. Okay. So one of these changes was about getting the plugin framework to give a plugin ID to your plugins. That way, the plugins can sort of namespace their own metadata and tool names. And I guess this was when a plugin ID isn't available, it would use the file system path. Story ACs don't prescribe fallback behavior. Edge case is narrow, most exports are named, and file system path plugin ID is ugly but functional for namespacing. I agree. Having a path as a namespace in either a metadata field or in field names, that does not sound ideal. So I agree with the judge there. Session ID never validated against fetched message. DB query only filters by message ID, not session ID. Judge rejected is not valid. This is an established code-based pattern. That is exactly the kind of thing that the judge is supposed to find. If the code base already has an existing pattern or a bug or deficiency or whatever the reviewer might find, if it's already existing in the code base, we reject it. That would be different if the entire project was like a refactoring project and we're supposed to be changing that kind of stuff. I haven't done that kind of project with this development loop. I don't know what the judge would think in situations like that, but I suspect it would be fine because it would be all laid out in the planning ahead of time. So I'm very happy with this rejection. AC4 requires AC4 is acceptance criteria number 4. Acceptance criteria are defined in the story documents or in the epic document. Requires message v2.get, but implementation inlines a raw query. Judge rejected out of scope. Message to v2.get is async and returns with parts. The transaction callback is synchronous and only needs info. The spirit of the AC is satisfied. Extracting the shared helper for a 2-line duplication isn't justified. Huh. Okay, sure, sure. I do have information probably in the reviewer document that talks about the trade-off. No, it's in the planning document, I think. It talks about the trade-off of allowing code duplication versus refactoring and writing shared code. This is one of those things that's a trade-off. On one hand, I feel like duplicated code is always a bug that will be discovered at some point in the future because inevitably one of those things will be changed. And usually, if that happens, both of them should have been changed, but only one was. And when that happens, the other one is a silent, what do they call it? A Heisenbug? Like a bug that exists but just hasn't been triggered yet until the future when that code path has a negative outcome because it wasn't modified in the same way. So for human developers, I usually lean towards the side of do not copy paste code. Don't have duplicate code anywhere unless it's obscenely complicated to extract it into shared code. The trade off is if you extract something into a shared module, you now have an explicit dependency between different parts of your code. Whereas with duplicated code, there may be an implicit dependency or there may not be. And sometimes you don't know at the time of development. It only shows up later on. Anyway, it's one of the trade offs. And with LLM developers, they very frequently miss these places where there's duplicate code and one place needs to be changed and the others don't. So I put in there that if you are accepting duplicate code, you should add comments that say this other code over here probably should be changed if this one changes, and I have them both reference each other. And that I think is probably acceptable for LLMs when they are making the trade-off about duplication versus like a refactor where you extract it out into some shared code. So yeah, it rejected that. Uh, I might take a very close look at that and look at it specifically, but I suspect that I will agree that the duplicate code here is okay. Unsafe is any cast between SDK message and internal message v2.info. Judge rejected as over-engineering. This is a standard package boundary pattern. Runtime validation via message v2.info.parse already catches structural mismatches. Adding compile time coupling between SDK and internal types is counterproductive. Maybe. I don't know. I might want to see that. Inline draw query. db.select from message table where message table ID input.message ID.get. If it doesn't exist, throw an error. Info equals message.data, message.id, session, message.session ID as message v2.info. Okay. Oh, okay, okay. So because this is being done in a database transaction callback, it can't really use the async message v2.get. That's very valid. I'm still not sure that we want a raw query here. I'm going to have it look through the code base and find out if there are any other cases that do raw queries. And I'm going to look for any place where there is an entire method just for doing a query that is only used in one place. This is another one of the things where I'm looking in the existing code base to see how the authors currently prefer to structure their code, so that I'm sort of replicating their existing behavior rather than doing something odd that they're going to see and maybe get the ick factor of, oh, why did you do that? I'd rather just look at the code base and see if there are already examples of either this way or the other way. M1, the as any cast, update message ID function, update message atomic, session ID, mutate function. Okay, the plugin callback types function as a draft message to void SDK type, but update atomic message expects message v2.info to void. Okay. So message to void instead of message v2.info to void. The as any bridges the package boundary. Runtime safety comes from message v2.info.parse. Okay. Yeah, I think that's fine. Oh yeah, because these are plugins are going to be like entirely separate packages. We don't really want. Yeah. I think this is fine, but I do want to look further. Um, okay. So I'm asking it to look through the code base to find out if there are already methods that primarily just exist to do a query, and is that method only used once? If that's the case, then maybe it's better for us to create a method to do this query and call that method instead. Or are there places in the code base that actually do raw queries like this because it's a one-off? It doesn't make sense to make it its own method yet. Go. Codebase overwhelmingly uses raw inline queries. Perfect. I'm leaving it as is. The judge was correct. That's fantastic. Great. Then that means this project or this initial part of the project of modifying OpenCode in order to support my plugin is done. I'm gonna have it run the test suite just to see it for myself. The developer is already supposed to do that. I'm pretty sure there's git commit hooks that force that as well, but I just want to see it. So now I'm having it run those tests. OpenCode, I found in the version I was working on before, which I started working on this a couple months ago. And at that point, there were tests that have external dependencies. They're labeled in here as enterprise tests. And they need they make service calls to an actual running service and need API keys and such. So I've told it to run all the tests except for anything that needs external dependencies. Okay. So while that's going, oops, whoop, whoop, we can read the reviewer subagent instructions. Okay, so here's the reviewer document. When the orchestrator launches a reviewer, it gives the reviewer, the subagent, the path to this file, and it tells the reviewer to read this file. So it's given the mission of evaluating the implementation of a story. Figure out what's wrong, missing, or could be improved. Your job is not to approve work, it's to find problems. Critical mindset. So some of this reviewer document I took from a framework called BMAD because I had my own reviewer document at one point and it worked fine in this process. But then I tested out a framework called BMAD, which is sort of it's a similar process where there are multiple agents. The agents have different roles, and you create a plan and you have it implement that plan similar to what I'm doing. And that framework has a reviewer agent. And when I used it, I really liked its output. And I looked at the license and pretty sure it was MIT. It was some license that was acceptable for copying into my project. So I copied that over and added a note in the repository that says, you know, this is influenced heavily from the BMAD project. So this document has a lot of stuff from that project that's really cool. So some of this is either directly taken from or very influenced by that project. BMAD, let me see. Put this over here. BMAD method, that's what it's called. BMAD method. Breakthrough method of agile-driven, AI-driven development. Actually, the very first big project that I worked on for using LLMs beyond either like code complete or directly interacting with it and modifying files, I quickly realized that I want to have this process where I design my changes first. So I created something very similar. I had a project manager and a developer, and there was another big part of that process. I can't remember what it was, but I would talk to the project manager, and its purpose was to help me get my thoughts out about the changes I'm making and sort of pull questions out of me to help me fully flesh out what I want to do and convert that into a plan that the developer can then implement. And then I would have the developer implement something. Oh, it was a reviewer. So I had a reviewer and I said, you're a senior engineer at a FANG company, and your job is to catch significant issues before it goes into production. So I had a sort of a system kind of like that, similar to BMAD. BMAD also has a project manager and a developer and sort of these workflows that you go through. So that's what that is. Pretty cool. I just found it very cumbersome to work with overall. It's extremely strict about what your plans look like, and when its developer is working on a plan, it follows it extremely strictly, and it's really difficult to sort of like add changes in the middle of the process. Like if you discover, oh, the plan, I was missing something and I really need something else, the developer will kind of refuse to do that unless it's in the plan. But the plans are very strict and they follow a strict rule. So you kind of need the BMAD tools to create that plan. But getting the whole system to modify the plan that existed, it didn't really work well. And then if I just ignored the plan, the BMAD method entirely, and just worked with a subagent on my own to make the updates I needed, and then come back, then it would still have problems because now the project doesn't match the state that the plan is expected the project to be in. So I gave up on it, but I took a lot away from it that I really appreciated. And it was super interesting that someone had done something the same as I had, but had gone super in depth and spent a whole lot more time than I spent on mine. And, this thing is way more fleshed out than anything that I made in the same sort of spirit. Okay. Yeah. Oh, let's see if the test passed. All tests, 0 failures. Great. That's good enough. So I think, oh, there. I think I'll get through these documents for the reviewer agent and the developer agent. The developer agent doesn't need a lot to go through. It's basically just following the stories. But we'll go through these and then I'll end the stream. Tomorrow's stream is going to be creating the plan for the next phase, which is going to be the actual plugin part that uses the changes that we just did here. Okay, so the reviewer, be skeptical, assume the developer missed something until proven otherwise. Verify everything, don't trust claims, check the code. Yeah, because the developer obviously thinks it was done. It says, I finished the thing, I implemented all of this stuff. Lies. So this thing has to actually verify it and prove it's true, actually look at the code, not what the developer said. Find real issues, genuine problems, not fabricated ones. Be thorough. Looks good without evidence is not acceptable. Check get reality, verify that the claimed changes actually exist. And manage command output, use safe inspection techniques to avoid context overflow. That was probably added by me at some point. So when LLMs are looking at code, it can read an entire file and then that file can be too big, or it can read logs or something. It can be much too large and either not fit in the context or just use up way too much context. So there's ways that it can read the code in sections, and I encourage that through most of the things that I do with LLMs. Right here, it's specifically highlighted in this document. Output management, and here's specific methods of how to do that. Long-running process management. Never run application or servers without a timeout or background. They will block and cause failure. So the main thing is sometimes the LLM will launch a process, and the process can be, for instance, a web server, like a development web server. That just starts and stays running. It doesn't daemonize. And so at the current state, when LLMs run commands, they typically run them in the foreground, which means the LLM control, the harness's control is sort of handed off to a subprocess. And until that subprocess finishes, the harness can't do anything. It's just waiting on the subprocess to finish. So if a web server is started and the LLM is expecting to do things after that, maybe interact with the web server, it can't. It just hangs forever. So that's why this part exists. It needs to background processes or use timeouts. This talks about the handoff between the orchestrator and the reviewer. What information should it expect to receive from the orchestrator? And then it is told to actually read the files that the orchestrator told it about. So these are all the various placeholder things that we talked about in the orchestrator document. The orchestrator is responsible for actually resolving these placeholders and figuring out what they should be, so that the reviewer and the developer can actually read the files and get the file contents into their context. And it needs to get all the acceptance criteria, get what files should be created or modified, and the technical requirements and patterns. Should examine the changes. Now, the adversarial review. This part is very heavily influenced by that BMAD document, or the BMAD framework. So most of this is, well, I started out by simply replacing my own with, no, I don't think I replaced my own. I think I worked with an LLM and I said, here's my reviewer document, here's the BMAD code base. It has a similar thing. Go find its equivalent and incorporate what it does into my own document. So I'm not actually sure what originally came from me and what came out of that BMAD thing, but I think, well, the reviewer behaves way more like the BMAD reviewer now, so I think most of this is from that. Okay. Okay, acceptance criteria validation. For each criterion in the story, make a table, and figure out if it's missing or only partially implemented. If the story has subtasks, I verify that each is actually done. Yep, makes sense. Review the quality of the code, look for security issues, error handling, for performance issues, code quality. Dead code analysis, very important. That's one of the things that LLMs are bad at. The LLM will, let's see, it will maybe write a method that completely replaces some other method that used to exist. And now that other method isn't used anymore, but it will just leave it there. So it's necessary for the reviewer to look for dead code. Same exact thing for documentation. As the project changes, the documentation needs to change. And sometimes there's old documentation that references old stuff that was there at one point in development, but we changed stuff so that the documentation either needs to be, removed entirely or modified to match the current state. Various architecture issues, dependency changes. Every dependency change has to have a good justification. That's another thing, especially with Claude Code. It will it'll figure out how to complete its task. Its main goal is complete its task, and it doesn't think heavily about code quality and dependency changes. It'll just randomly add dependencies, even when there's already a dependency that does what it needs. Like a testing library is already in the project. It can add a whole new testing library that's completely unneeded, and that's pretty irritating. So the reviewer looks for those, and it needs a justification about why this dependency change happened. Project-specific standards. So yeah, if the project has like coding standards or a style document or whatever, it makes sure it follows those. Makes sure that there are sufficient tests and that the tests have the right level of coverage. Integration issues. So a lot of the plans that I work on are sort of done as I work on them in parallel as separate projects. So I'll have, this is one example where there's a set of changes to OpenCode. Usually I would have been working on these in parallel. A set of changes to OpenCode and then my plugin itself. And there's a contract between them. And so that contract needs to hold. Otherwise, these parallel development efforts, once I put them together, they aren't going to work. Similar is true so when the plan is developed, it figures out what can be done concurrently or sequentially. And for that to work, it needs to have certain contracts that happen. And same thing, if those parallel developments happen and then come together and they are not matching, then that causes issues. So the reviewer does look for these integration issues. And then it also makes sure that the commit messages are happening as expected, that there aren't unrelated changes. So sometimes I have it do work as Git work trees, completely separate, and their own working on their own branch, and then they come together and merge. Or sometimes they're just working in the same branch on different parts of the file system. And that's when changes can leak through into commits for like different parts. This reviewer is meant to catch that part. Okay. Thoroughness requirements. That's what I've mentioned with the developers. They'll finish part of the job and think they're done and say, I did all the work. The reviewer needs to catch that all the work did not finish, or it did finish. Lots of, LLM quirk things are here. Things that the LLM typically, skips or does poorly. Those things go here. And then, let's see, then it generates the report. And this report is what goes to the orchestrator, and then the orchestrator will hand it to the review judge. So this just defines what the report should look like, all the findings, the criticality of those findings. If it didn't review files, it lists what it didn't review, and that can be that can happen due to parallel work being done in the same branch, or it can be, well, it's still parallel work, I guess, if the LM is doing something, but I'm also doing something on the side. There can be files that weren't part of the story, but were still changed. It will list them here. Guidelines for what to mark at various criticality levels and what not to mark. Things like I would have done it differently. When there's trade-offs and they're like stylistic, don't mark those wrong just because, I don't know. There's various things that if you just randomly ask it to review something, it'll just mark issues on things that aren't really issues. Just it would have done something different for whatever reason it thinks it's worth bringing up. So yeah, I work against that LLM quirk here. Over engineering things, features that were added that are not in the story requirements, things like that. And then finally, it's not trying. Okay, here's a big one. With the current generation of models, and especially like a year ago, the models are extremely sycophantic, and they want to help you get things done. They want to satisfy you. So if you're asking an LLM to review your code and approve it, it's more likely to approve it even when there are issues. So here it very specifically says your job is to find problems. Your job is not to approve the code. And then when you do find problems, say specifically what file and line and what's wrong and how it can be fixed. So that's the reviewer document. The developer document doesn't really need a lot of explaining. Um, it's things about, read the documents, follow them carefully. Here's how you complete the work, how you do get commits, things like that. Output management we talked about with the reviewer one. That's where when it runs a tool call that could generate a large output, and this could be reading a file or it could be executing a bash command. That bash command might be much too large and damage the context window. So this is that same stuff about how to deal with that. And there are specifically things that I know frequently trip it up. So I list those here. If you're running git log, make sure that you limit it properly using the techniques that were described above. Long run, same thing with the long running processes. I mentioned, it might want to run a web server. Never run these. Yep, similar stuff. Like any of these things that it's trying to run, it should run it in the background with a timeout. More techniques about reading files. Okay, and then similar stuff we saw in the other documents. Here's where the project documents are, the story, where the research lives, figure out your dependencies, look at the acceptance criteria and figure out what files you're going to modify, plan the order that you're going to implement things in. And then there's coding standards, error handling, code organization. So if you don't explicitly tell it to think about the code organization, it can sort of generate files in random, unexpected places. So just mentioning it, asking it to sort of understand the existing organization is a good idea. Stub documentation when it's creating a stub that will be filled in by a later story. I have it do that in a specific way here. It's told to add tests. It's told to commit a certain way. And in the previous document for the reviewer, I mentioned that dependency changes are a big issue with LLMs. So there's a whole section in the developer document for dealing with dependency changes. And then before you call this work complete, make sure, again, that all of these acceptance criteria are met. And then generate a report. And again, this report is handed to the orchestrator. Then the orchestrator can hand that report to the reviewer and say, here's the things that the developer did. And here's the revision part. So if the reviewer identified revisions that are needed and the judge approved those revisions and it comes back around, here's the guidelines for handling the revisions. And again, all of these reminders, limit your implementation just to the story. Don't add random features. Prefer minimal working solutions over elaborate architectures. I don't want it to go broad and start making lots of changes. Like I said before, I prefer all of the decision making to happen in the planning phase. If it's going and making crazy architectural changes, it's going to be making a lot of decisions that I have no influence over. And so far, with the current state of LLM models, I've been unsatisfied is a light way of putting it. Like, the LLMs will make embarrassingly bad choices if left to their own means. At least in this method. I could imagine if I was doing Ralph loop methods, I would probably be building documents about how to decide what kinds of architectural changes to make in certain places. And that would be like a whole different style of development. But for the way I do it, I do not want the LLM going off and doing architectural choices on its own. Yep. So anyway, that's the developer document. So you've seen this sort of like, I guess it's 4-document system that I have. There's the orchestrator, the developer, the reviewer, and the review judge. And it goes on this loop, and it goes through iterations until the reviewer is satisfied, and the judge, either until the reviewer is satisfied or the reviewer only has minor things that the judge discards and says are not necessary. And it will progress through all of the tasks until the entire project is complete. And then it sends me a message on Slack that says I'm done. And I move on to the next one. All right, I think I'll end the stream here. So yeah, the next stream, we're going to be developing the plan for the actual plugin. And the plugin is going to use the changes that we just made. All right, thanks.